We're going to go ahead and continue a little bit with chapter 9 or chapter 10, I guess it is, in Myers. And now that you know a little bit about theories of intelligence, we're going to take a look at a couple particular ways, two or three ways, that people over the years have tried to measure intelligence. So it's kind of interesting because intelligence is something that it's very difficult to determine what it is. And so, if you're having a hard time defining what intelligence is, then you can imagine how tough it is to test it. To actually determine a way to test it. So, years and years ago, people used to believe that brain size and intelligence went together. And so, essentially, the larger that someone's head was, the theory, compared to their body type anyway, the theory was that their brain must be bigger and therefore they must be smarter. Well, actually, now that we have a lot more science to it, we've studied this and found there is a positive 0.5 correlation between head size and intelligence scores. So, what does a positive 0.15 correlation mean? Essentially, there's very little link there whatsoever. It's very, very, very weak at best. So, that brings us to another question, and that is how about the brain size, the actual brain size and IQ? And using an MRI, scientists have actually calculated that there is a positive 0.33 correlation with brain size and IQ. Now, what does positive 0.33 correlation mean? That basically means that there is somewhat of a correlation. It's not a strong correlation by any means, but there is a rather small correlation between brain size and IQ score. Now, does that solve everything? No, but it does bring up some other questions. Okay, scientists have also looked to see if the functioning of the brain has anything to do with intelligence. And what they found is that higher performing brains tend to be actually less active than lower performing brains. Maybe that's reverse what a lot of people would have thought, but that is what they have found. Now, they have found that the neurological speed tends to be a little quicker. So the brains work a little faster, but in terms of like the overall work, they tend to be a little less active. So now let's take a look at one guy years ago, Alfred Binet. People were basically trying to figure out, what do we mean by intelligence and how do we measure intelligence and things like that. Well, Alfred Binet actually was looking at a little bit different question. Binet was a Frenchman who was wanting to design a test that would identify children who needed special attention in schools. So what he was trying to do is figure out a way to kind of identify those kids by coming up with some sort of a standardized test. So between him and a guy by the name of Theodore Simon, they basically came up with the construct of what we call a mental age, a person's mental age. So as you can see in this cartoon, this gentleman is obviously a little bit older than 5 years old, but the ladies are laughing about the fact that the 5 candles represent his mental age, not his chronological age. So let's take a look at how Binet's concept and his idea then transferred over into an actual IQ test. And that was where Lewis Terman, who is a professor at Stanford University, he used Alfred Binet's research and his concepts to basically create what we today call the IQ test. Technically, it's the Stanford Binet IQ test, and it's one of the major IQ test that we look at today. Now, again, it's based on a person's mental age and their chronological age, with the idea that the older a person gets, the smarter they become. Okay, so in other words, a 12-year-old should have a mental age, a 12-year-old chronologically should have a mental age of 12. But a 14-year-old person should have a mental age of 14, and that there's a difference between a 12-year-old and a 14-year-old, with the 14-year-old being able to do more complex things. So the Stanford-Binet IQ test is actually set up so that it asks you a variety of questions in a variety of different ways, but the idea behind the whole thing is that, like, a 6-year-old should be able to do certain questions but not do anything above that 6-year-old level. An 8-year-old should be able to do a little bit more but nothing above the 8-year-old level, and so on. So Terman actually came up with a way to calculate and basically turn the IQ score into a number. So the intelligence quotient, that's what that stands for, IQ, the intelligence quotient equals the mental age divided by the chronological age, and then you multiply by 100. Now, it was kind of interesting because he faced a dilemma. What do you do as adults get older and older and older? Are you going to have certain questions that a 55-year-old should be able to answer that a 56-year-old shouldn't be able to answer? That's getting a little tough. So Terman basically said that, by the time that adults get to be about the age 20, that all adults should be able to do certain task. So if we that's why he basically assigned all adults the chronological age of 20. Now, if we look at some questions here, okay, let's take these. An 8-year-old has a mental age of 10. What's her IQ? Well, if you plug it into the formula, okay, first of all, before you even plug it in, just think about it for a minute. What is an average person going to have an IQ of? Okay, a 9-year-old should have a mental age of 9. So 9 divided by 9 times 100. Okay, that's going to be 1 times 100, or 100. A 15-year-old should have a mental age of 15. So 15 divided by 15 is 1 times 100. So essentially, the average IQ score for anybody at any age should be 100. So if we take a look at this first problem again, without even calculating, we've got an 8-year-old who has a mental age of 10. What does that tell you? Automatically, that tells you the IQ is going to be higher than 100. So we plug in the numbers, the mental age, 10, divided by the chronological age, 8. That's going to give you a total of 1.25. Multiply that by 100, and you come up with an IQ score of 125. A 12-year-old who has the mental age of 9. Now, this obviously is going to be a number less than 100. Okay, so if we, again, plug in the scores, okay, mental age of 9 divided by 12. 9 divided by 12 is going to be 0.75. You multiply that by 100, we end up with 75. Now, this gets a little bit more complex, but still you can figure it out. And you math majors, so it's an easy thing for you to do. But once you fill in the blanks, basically, a boy has a mental age of 10 and an IQ of 200. How old is he? Well, on this screencast, to be honest, I'm not going to go through the math part of that because it's not that important for us. But if you figure that out, basically the chronological age is going to be 5. Okay, so that's what we're looking at in terms of calculating that. Now, that is the Stanford-Binet IQ test. It's based on Alfred Binet's work, and then the University of Stanford professor Terman his kind of using that information to create that test. Let's look at one other test. When I say one other test, technically it's one other person who's kind of created a variety of different tests. David Wechsler has used basically a different way of measuring intelligence. He doesn't use like a mathematical formula to find a quotient, but it's still called an IQ test. He actually has 3 different tests. There's one for adults, the Wechsler Adult Intelligence Scale. There's one for kids, essentially about ages 6 to 16, and that's the Wechsler Intelligence Scale for children. But he also has one that he also has for kids as young as 4 years of age, and that's the Wechsler Preschool and Primary Scale of Intelligence. So that actually goes down to, again, where kids can be as young as 4 years old. But everything that he does and all the way he calculates the scores are based on how many standard deviations a person is away from the mean. Now, again, it's a standardized test, and so standardized test, the mean, the median, and the mode are all the same, and they all equal one another. And essentially, there's the same number of people above the mean as there are below the mean. So we'll study that here on a different screencast here in just a minute. But essentially, the tests are still set up so that the mean is 100. So even on the David Wechsler test, you can kind of compare it with the Stanford Binet test because, for example, if a person has an IQ, let's say, of 85, well, then that's below normal. If they have a score of 110, that's above normal. But it's all based on how far away from the mean the person is. Okay? Now we'll stop at that point and we'll take a look at this particular slide on standardized test. We'll take a look at that at a different screencast.